Welcome to This Explainer. Every major technology shift has that one defining moment, right? That moment when it stops being this abstract sci-fi concept and just starts being your regular Tuesday morning. Well, for artificial intelligence, that moment is literally right now. But let's be honest with ourselves here. As developers, we're currently being bombarded by product managers asking us to just sprinkle some AI onto our features. Yet a lot of us still don't actually understand what's happening under the hood. The signal-to-noise ratio is completely out of whack right now. You've got marketing departments and academic research papers throwing around the exact same term, AI, to mean entirely different things. So today, we're going to fix that. We're going to completely strip away the hype and build a rock-solid, jargon-free foundation, starting right from first principles.
Okay, let's dive into this. Here is our roadmap for today. We're going to break this down systematically. First, demystifying artificial intelligence. Second, rules versus examples. Third, the training process explained. Fourth, narrow versus general AI. Fifth, a brief history of AI. And finally, why today is actually different.
All right, part one, demystifying artificial intelligence. Let's start right at the foundation.
If you've been feeling completely overwhelmed by the absolute flood of AI news lately, I want to assure you, you are not behind. To cut through all that marketing noise and those wild startup pitches, we have to stop and ask ourselves a core question. What actually is AI? When you pull away the glowing blue brains and all the sci-fi tropes, what is the fundamental technology we're really talking about here? Well, here is a truly robust, totally jargon-free definition for you. AI is simply software that learns from examples rather than following fixed, handwritten rules. It improves its behavior by processing data. So when you hear the word intelligence in this context, definitely don't think of human consciousness or a mind. Think of it more as dynamic, probabilistic pattern recognition rather than the strict, deterministic logic you're probably used to writing every day.
That takes us to part two, rules versus examples. This is where the massive paradigm shift happens.
To truly grasp this new frontier, we really need to contrast it with the traditional software development process we already know so well. In traditional programming, it's a completely deterministic, rules-first philosophy. We, the humans, explicitly write the rules. Think of all those if and then statements. The computer just perfectly executes them. It's totally predictable, it's auditable, but it's also incredibly brittle at the edges, isn't it? Because every single new edge case requires a developer to go in and write a brand new rule. Now, and this brilliantly illustrates the change, machine learning flips this entirely on its head. It is data first. The system actually derives the rules from the examples you provide it. It's incredibly flexible and adapts to new patterns automatically. But of course, that comes at the cost of being way less interpretable.
Which brings us to an absolutely crucial realization that all of us developers just have to internalize. AI systems are not programmed, they are trained. Instead of sitting down and explicitly writing out logic, you are showing the system thousands or even millions of labeled examples. The model then develops its own internal weights to learn those rules entirely on its own. So, how does that work? Let's get into part three, the training process explained, the mechanics under the hood.
Let's completely remove the magic from the machine for a second and look at how that training actually happens. Training is just how an AI model develops its understanding. Honestly, you can think of it exactly like preparing for a massive exam by grinding through practice problems rather than just trying to memorize a textbook. The loop basically looks like this. First, you collect the data. Next, you do a forward pass where the model makes a guess. Then, you measure the error of that guess. And finally, you adjust the weights inside the model so it can be slightly more accurate the next time. Now, this loop runs billions of times to encode those patterns. And the end result? A trained model isn't neat, readable human logic. It's a massive, giant table of numbers, a matrix of weights and parameters that transforms inputs into outputs. This means you literally can't just step through it with a debugger. It is a genuinely different craft.
Let's ground this abstract training concept using something super concrete and familiar, spam filters. Remember those back in the 1990s? Those rule-based spam filters used simple block lists and basic keyword matching. Spammers bypassed them almost instantly by just spelling things slightly differently, like replacing an E with a 3. But modern machine learning-based filters? They're trained on millions of labeled emails. They catch novel phrasing and weird behavioral patterns without a single human engineer ever having to specify them. Actually, this was one of the very first mass-scale deployments of machine learning that developers out in the wild really relied on. Moving to part 4, narrow versus general AI. let's talk about the capability spectrum.
Now that we know how it works, we really need to puncture the sci-fi hype balloon for a minute. The foundational concept you need here is narrow AI. This is an AI that excels at one very specific task. And don't get me wrong, it can be entirely superhuman within its designated lane. Think of a radiology model detecting tumors way more consistently than top human experts. That's amazing. However, it is incredibly brittle outside of that lane. Even tiny little changes in data outside its specific domain can cause it to fail completely. It just cannot generalize.
So, the crucial point is this. Here is the reality check you need to keep in your back pocket. Absolutely everything in production today is narrow AI. The whole shebang. From image recognition on your phone to the recommendation engines on streaming sites, they are all narrow. On the flip side, we have AGI, or Artificial General Intelligence. This is the stuff that matches human cognitive flexibility. Right now, AGI is purely hypothetical. To be totally clear, there is absolutely no general AI in the world today, only extremely good, very convincing, narrow AIs. All right, Part 5, A Brief History of AI, the journey from theory to today. To truly understand where we are right now, we have to look at the chronological road that got us here. AI development actually has a surprisingly long history. Way back in the 1950s, Alan Turing formalized the whole concept of machine intelligence. Fast forward to 1997, and we saw this huge, very public milestone with IBM's Deep Blue victory in chess. That event completely shocked the world. It proved that machines could conquer incredibly complex strategic domains. But the real modern turning point? That happened in 2012, with the breakthrough of an algorithm called AlexNet. That single event officially initiated the deep learning revolution that we are all currently living in.
You might be wondering, why was 2012 so vital? Well, it represented this perfect, massive convergence. For the first time, we had the neural network algorithms, combined with massive data sets generated from the early internet, and all of it was finally powered by the raw, incredible compute of modern GPUs. This triad, algorithms, data, compute, kickstarted a massive data flywheel. It spread like wildfire, accelerating AI development at an unprecedented rate and creating huge structural advantages for early adopters.
Which leads us perfectly into our final section, Part 6, Why Today is Different, Looking Beyond the Hype Cycle. Given that AI has definitely had hype cycles before, we've seen AI winters in the past, why is this specific moment in history different? Well, it comes down to three accelerating factors that are driving modern product development right now. Now, what's really interesting about this is, first, model scale finally crossed a massive threshold, leading to entirely new emergent abilities that researchers didn't even explicitly train for. It just happened. Second, we now have general-purpose interfaces that can handle text, audio, and video completely seamlessly. And third, maybe most importantly for us, API access has completely democratized AI. Meaning, literally any developer can build with world-class models over a weekend afternoon without needing a PhD in computer science. As developers, you should treat this as your practical cheat sheet for the very next time you're scoping out a feature. Current systems, they are reliably excellent at pattern recognition, content generation, and summarization at massive scale. That's their sweet spot. However, they still deeply struggle with reliable multi-step reasoning, strict factual accuracy, and understanding true causality. Knowing these limitations is just as important, if not more important, than knowing the capabilities. I want to wrap up today's explainer by throwing this over to you to think about. What was the very first AI system you remember encountering in your own life? And based on the mental model we just built today, was it actually learning from data, or was it just faithfully following explicitly written rules? Keep chewing on that, because in our next explainer, we're going to dive deeper and draw the precise technical lines between artificial intelligence, machine learning, and deep learning. We'll explore exactly why those specific distinctions matter for your daily work. Thank you so much for joining me on this journey today. Keep exploring, keep questioning, and I'll catch you in the next explainer.